In order to graph this piecewise defined function, we must first consider the graphs of the individual pieces. So we begin by recalling the graph of abs_val x and the graph of y is equal to x plus 5. The absolute value of x is the graph that looks like a V, and let's label an ordered pair here 0, 0, since it passes through the origin, and since 0 seems to be a point of transition, a place where we go from using one graph to using the other. I needed to change my Cartesian plane a little bit here to get the graph of y is equal to x plus 5, because it has a y-intercept of 5 and then a slope of positive 1. So we'll go up 1, right 1, but we could also go down 1, left 1. Let's graph this line and also take note of the ordered pair 0, 5. Now to get the graph of g, every single x value that is not equal to 0 is going to come from this graph. So we'll draw an open circle around x is equal to 0, but everything else is going to be copied from the absolute value of x graph and pasted onto our final answer over here. So we have an open circle at 0, 0, and we get the rest of the absolute value of x graph. Any ordered pair whose x value is not 0 comes from this graph. Now for the second piece, what we see is we're only getting one ordered pair here. We're only going to grab the ordered pair where x is equal to 0. So this one point is the only thing that we pull into our final answer graph. Let's label this point with 0, 5 and this point with 0, 0 so that we can clearly see what's happening at that transition point. Notice here again that this final answer graph does pass the vertical line test, which it should because this is a piecewise defined function.